Welcome to myprojectbazaar.com. Our product title is Hybrid LUT Multiplexer FPGA Logic Architecture. Next we see about abstract of our product. The digital architecture is mainly used in all type of real-world application architectures, and thus the architecture to modify based on the enhancement purpose. The VLSI technology is to optimize the any type of digital architecture. The proposed architecture are implemented using a modified version of the mapper in the ABC logic synthesis tool. The VPR is used to model the new hybrid configurable logic block and verify post, place and root implementation. This hybrid configurable logic block that contains a mixture of LUTs and hard-entered multiplexers. It towards the goal of higher logic density and area reduction. Mapping techniques targeted towards the hybrid CLP architecture that optimizes for area. This area could be large as it includes not just the logic function but the expensive programmable routing required to connect it. This potential waste motivates us to look for other ways to make use of these structures. Two factors this affected: one, the decoding logic may be share the same select signal, and two, digital designs contain decoded multiplexers. The first factor, reducing decoding logic, is due to multiplexing buses. These buses share multiplexer selected signal. The second factor, reducing decoding logic, is due to design containing decoded multiplexer and associated decoding logic. If decoding logic consists of more than one signal, then the multiplexer is best implemented as a decoded multiplexer. Next we see about flow diagram of our product. This is our flow diagram. First, the input data is given into the logic element. In the logic element consists various logic gates and multiplexer. Here we using AND or NOT gates and 4:1 multiplexer in the logic elements. Generally, logic gate is nothing but is an elementary building block of a digital circuit. Most logic gates have two inputs and one output. At any given moment, every terminal is in one of the two binary conditions, low or high, represented by different voltage levels. The logic state of a terminal can and generally does change often as the circuit processes data. In most logic gates, the low state is approximately 0 volt, while the high state is approximately 5 volt. And next in the logic element consists a multiplexer. Here a 4:1 multiplexer used, and multiplexing is the generic term used to describe the operating of sending one or more analog or digital signal it over a common transmission line at different times or speeds, and such as device we use to do just that is called multiplexer, and it is called as mux. It is a combinational logic circuit. It is designed to switch one of the several input lines that through it to a single common output line by the application of the control signal. After that, the output of the logic element is fed into the D flip-flop. Before that, what is logic element? It is nothing but it is smallest unit of the logic in the Cyclone 3 device family architecture. It is compact and provide advanced feature with the efficient logic usage. And next one, the output is fed into the D flip-flop. One of the main disadvantages of the basic SR flip-flop is a bistable circuit is that the indeterminate input condition, that is set is equal to logic 0 and reset is equal to logic 0 is a forbidden condition. This state will force both output to be at logic 1, overriding the feedback latching action, and whichever input goes to logic level 1 first will lose control, while the other input still at logic 0 controls the resulting state of the latch. But in order to prevent this from happening, an inverter can be connected between the set and reset inputs to produce another type of flip-flop that is called as a D flip-flop. And next one, the complex logic block. That block is contain the overall logic element D flip-flop and mux and output data in LUTs. In computing, a logic block or configurable logic block is a fundamental building block of FPGA technology. Logic blocks can be configured by the engineer to provide reconfigurable logic blocks are the most common FPGA architecture. Next one, the lookup table. A LUT, which stands for lookup table, in general term is basically a table that determines what the output is for any given input. In the context of combinational logic, it is the truth table. This truth table effectively defines how your combination logic behaves. In other words, whatever behavior you get by interconnecting any number of gates. Next, we see about running process of our product. In this proposed design is done in Xilinx 14.2 version. First, to open the Xilinx window, create a new file. In the new file, we create the design name. In this proposed design is a CLB, that means configurable logic block, so we define CLB. So in the CLB having various blocks, that is a logic elements mux and logic gates and or not and a deep block or included in the CLB blocks. After creating the coding, we simulate the coding. So click the simulation and simulate behavioral model. So we simulate the corresponding signal. The output will be displayed in the corresponding window. So this is the output window. First, initially the data are in a undefined format. That means D0 and D1 is input and S3 is a control signal, F is the output. So first that values are in undefined value. After we giving a corresponding value, the output will be changed in the corresponding manner. So this is a one part of the output. Next, another part of the output is a implementation design. In the implementation design, various reports are generated to simulate the synthesis XST and implementation design. In the synthesis report, we can able to view the device utilization summary and timing report. In the device utilization summary, how much of devices we used in the proposed design. That means LUT we used 48 and flip-flop 48 and banded input output BRAM range is 105. These are the using devices in the proposed design. Next one, timing report. In the timing report, how much time will taken to simulate the corresponding design. The time delay path is 1.1 nanoseconds. And next, after the implementation design, we can able to view the RTL diagram. And the next one, this is a technology diagram. The overall time will be reduced and overall area will be reduced using of this corresponding design. So overall efficiency will be increased by these factors. Thank you for watching this video.